Alright, so today we're going to be doing lesson 4-6, which is operations with radical roots. So we've been dealing with radical, nth radicals basically in the last few days. And now we're going to kind of put that together with our knowledge on simplifying expressions, okay, dividing expressions, multiplying, adding, subtracting. And we're going to combine that, and we're going to have some new rules that apply when we're dealing with radicals. So in math, we're used to adding and subtracting like terms, because terms have to be like in order to add them. Now the rules that apply to what are considered to be like expressions in terms of radical expressions, there's a few different rules that we want to address before we get into the lesson. So the first set here that I want to talk about is, the first rule that you need to know is that what's under the radical, which we call the radicand, needs to be the same in order for them to be like terms. So as you can see, it's 3x in both cases. The next thing that has to be the same in both cases is they have to be the same type of radical. So either they're both squared, cubed, fourths. Okay, basically they have to be the same type of radical. So this is squared, okay? Square root. This is a square root. Okay, if it were a cube root or a fourth root, can't have that. They got to be the same type. So they either both got to be cubes, both got to be fourth, so on. Okay? And the next thing that you want to look out for that would also make it not a like term is if it has variables outside of the square root that are not like terms. So as you can see here, these both have the same radicand and type of radical, but the problem is here, these are not like terms because they have x to a different degree. So make sure you're looking out for that. Like I said, they have to be the same type of radical and they have to have the same radicand. But I noticed the most common mistake people will make is the one where on the outside they will have a variable to different powers, and those are not like terms. Just like in math, we know that we can't combine x and x to the third power. So same thing. So let's go ahead and practice combining some of these that are like terms. So I'm going to zoom in here. So the first one here we're going to do, these are like terms. Do you guys see why these two terms are like terms? Yeah. They have the same type of root, square root, and they have the same radicand. So all we have to do here is combine the coefficients. So what's 3 minus 2? 1. So we end up with 1 radical 5x, which is also just radical 5x. You don't need to put that 1 there. Any questions about number 1? So let's move on to number 2. So we need to check and see if these are like terms before we do anything. So we have the same type of radicals. These are both cube roots. And then we have the same radicand as well. Yes?
Never mind.
Okay. And there are no exponents or variables with exponents outside of the square root, so I can just combine the coefficients. So what are my combined coefficients going to be? 12 plus 8, 20. So it's going to be 20, third root of 7xy. And that will be your final answer. So because they're like terms, you just combine coefficients, just like you do with any other like term that you've encountered in math. So the next one we're going to do is the fourth example. Now, are any of these like terms right off the bat here? No. So what we're going to have to do is we're going to have to try to make them into like terms by simplifying radicals when possible. So we can actually simplify this radical because we know that 12 breaks up into what? 2 and 6. We're going to circle the 2 because it's prime, and then 6 breaks up into what?
2 and 3.
3 and 2, good. So this is a square root, so we're looking for groupings of what size? 2. So we have a grouping of 2. So I'm going to write the answer over here as another line. So this is going to be 2 radical 3, because I have that other 3 that's left behind inside the radical. So now we're going to do the same procedure for the square root of 75. So what can I break up the square root of 75 into? 5 and 15. That works. Okay. And then what does 15 break up into?
3 and 5.
3 and 5. Now we're looking for groupings of what size? Good, groupings of 2, and we have that. So this is going to be plus 5 radical 3. The radical 3 is from the number left over that wasn't paired up. And is there anything we can do to simplify radical 3? No, so we're just going to rewrite the sentence with it at the end. So all I did was I just rewrote this as its simplified version, and I rewrote this as my simplified version, and I just wrote them all in a line, just like we had before. Now, what's the implied coefficient in front of the negative 1? Good, so that's important when we do our combining coefficients. So 2 plus 5 is? 7 minus 1 is? 6. So we end up with 6 radical 3, and that's your simplified answer. So far, so good? Okay. Now the last one we're going to look at is example 4. So I want to know, what do you guys think? Are these like terms? Yes or no?
No.
No. Why are they not like terms?
Because the coefficients don't have the same exponent.
Yeah, the x doesn't have the same exponent. Good. So notice the x right here has an exponent of 1, and this x has an exponent of 2. So these are actually not like terms, therefore they can't be combined. However, the rules say in the instructions that if we can't combine like terms, we want to see what we can factor out of these two. So what number could I factor out of both of these terms?
X.
I could factor out an x, but I can also factor out a number, 2. Good. So I can factor out a 2x, and they both also have the radical 5 in common.
Radical 5.
2x radical 5, very good. And then I'm just going to factor that out, and that
3
becomes?
plus 2x.
Good, 3 plus 2x. Good job. So that would be your answer factored. Now if you wanted to get back to your original, you would use what we call the, looks like this.
Distribution.
Yeah, distributed property or a form of FOIL. Good. So that's what we're looking for on example 4. So do you guys have any questions so far? Okay. So the next thing we're going to talk about is multiplying radical expressions. So in math, if you think about when you're doing an operation, do two terms have to be like terms to multiply them? No. They only have to be like terms to add or subtract them. Multiplication, division, you can definitely do that with terms that are not like. So when we do these, just keep in mind you can multiply things that don't have the same term. And the rule is, when you multiply two radicals, you basically are just going to put them both inside the radical and multiply together, okay? Anything that's on the outside of the radicals is just going to get multiplied together as well on its own on the outside. Now, one important thing that you need to know at this stage. Now, we will eventually learn in the future how to multiply two radicals that have different types of radicals, like a square root, and a cube root. But at this stage, we're only doing it when it's all the same. So you don't know yet how to do that. So I need you to ensure when you're doing one of these problems that they have the same type of radical when you're multiplying them, at least at this stage until you learn how to deal with it later on. So if they have the same type of radical, which these do, we're going to write one big radical, and what's going to go underneath is the product of what's inside. So what is the product of negative 4 and 2? Good, negative 8. And this one's actually a perfect cube, or perfect cube root. Anybody know what this is? Negative 2. Good. So negative 2 times negative 2 times negative 2 is negative 8, which makes it a perfect cube root.
Never mind. I thought you were asking something else.
Oh.
So I was like, what the fuck?
It's alright, at least you're trying to participate. Alright, let's go ahead and try number 6. So we have to use the distributive property here. So when you multiply two square roots together, it's just going to be the square root of the product of the two. And the product of 3 times 27 is 81. Plus, we can't actually do anything with 5 times radical 3, so we just leave it as 5 radical 3, because we can't really multiply them. And then we just want to simplify this as much as possible. So what is the square root of 81? Bless you. 9. So we end up with 9 plus 5 radical 3. Now, can we keep going or no? We actually can't add the 9 and the 5 because this 5 is associated with the square root. So these are not like terms. Now, realistically speaking, okay, if we're being technical, these are like terms because these are both just numbers, but one of these is an irrational number. So this is what we call simplest radical form. So a calculator will give you a decimal approximation of this answer if you wanted one. But, you know, if we're giving it simplest, we want it in simplest radical, make sure you leave it like that. Now this one here, first thing we do is check and see if these both are the same type of radical, which they are. They're both fourth root. And we're just going to multiply everything on the inside. So 48 times 15 is actually just 720. And then does anybody remember how to multiply variables to different powers? What do we do with the powers? We add them. Very good. So that's going to be 5 plus 3, which is 8, not 7. I was doing the next one ahead of myself there. So we're adding the exponents on the x. And then what is 7 plus 2? 9. So y to the 9th and then z to the 12th. Good. So we're taking the fourth root, meaning we're going to factor this and look for pairs of, or groups of, 4. So 720 breaks up into 16 and 45. Now you could go about it differently, but this is just the way that I remembered. So 16 actually breaks up into 4 and 4. And each 4 breaks up into 2 and 2. Now 45 breaks up into what?
5 and 9.
Good, 5 and 9. And then 9 breaks up into 3 and 3. So do we have any pairs or groupings of 4?
Mm-hmm.
Which one?
The 2.
The 2's only. Everything else didn't get grouped up. This is a 3, by the way. So what gets to leave the radical is the 2. Because it got grouped up, so it gets to leave. I'm leaving myself space for the rest of the terms. And then what has to stay behind inside the radical? What numbers?
3 times 3, so 75.
That's 45, yeah.
45?
Yeah.
Oh, wait, why does it sound 5? Oh
It's
my
okay.
God. Yeah, 45.
Yeah, so the 5, the 3, and the other 3 have to stay behind, which means we have 45 left inside the radical. That's just the product of what's left behind. And now we're going to do our exponents, our variables to exponents. So is 8 evenly divisible by 4?
Yes.
Yes, and how many times? 2. So this is x to the second. And is 9 evenly divisible by 4?
No.
No. It goes in how many times? Twice with a remainder of 1, and the remainder term goes back in the inside of the radical. And then lastly we have z to the 12th is 12 divisible by 4?
Mm-hmm.
Yes, 3 times. So it's z to the 3rd. So we end up with this as our answer, but this isn't the final answer because we have to go through and see if we need to put any absolute values. You guys remember I have to put absolute values around some of these? So we have even, even, even. That one's good. We have an odd. We can have an odd here. We don't have to worry about it. But we have an even, even, and then an odd. So we have to put an absolute value around the z. Okay? So don't forget about that step. So that's just what we learned back on Wednesday. Alright. So let's move into these problems. So number 8, we're going to multiply these together where it's the sum of a number and a mixed radical number. So the easiest way to do this is just to use the area model. So you're going to put one of them on one side of the box and one of them on the other side of the box. And then you're just going to multiply the corners. So this comes out to be 5 times 4, which is 20. 4 times 4 radical 2. Anyone know what that is? 16 radical 2. So you just multiply the outside numbers, and then you multiply the radicals and the outside numbers separately, okay? The coefficients. Yes.
Okay.
Yes. And then you're going to do the same thing here. So what's 2 times 5? 10. So it's 10 radical 2. And then lastly, we multiply our outside numbers first. So it's going to be 8 radical 4. So I multiplied the insides. Now you're going to notice that these two terms are like terms right here. You guys see that? So I'm going to combine those. I'm going to rewrite it all out. So it's going to be 20 plus 26 radical 2. I just combine those two like terms because they have the same square root with the same radicand. And then lastly, I have 8 times radical 4, square root of 4. We can simplify that, right? Because what is the square root of 4? 2. What's 2 times 8? 16. So I just simplified this. And then as you can see, we have 2 more like terms to combine, which becomes 2 plus 16? 36. Good. So that will be our final answer. And those are not like terms, so you can't go any further with that unless you're trying to get a decimal approximation. So any questions on number 8? Alright, let's go ahead and do number 9. So same procedure. We're going to do the square root of 3 minus 4 radical 5, and then the square root of 3 and square root of 5, or radical 5. Same procedure. This is going to be radical 9, radical 15, negative 4 radical 15, and negative 4 radical 25. So I just multiplied the corners, and now we'll see what simplifies. So in this case, what is the square root of 9? Good. What is radical 15? This is really a 1 radical 15. So what's 1 minus 4? Negative 3. So we have negative 3 radical 15. I just combine these two like terms, and that comes out to be this. And then lastly, we have negative 4 times radical 25. What is the square root of 25? 5. 5 times negative 4 is negative 20. And then at this stage, you have two like terms to combine. 3 minus 20 is negative 17. Just like that. And that is our final answer. Any questions on that? Alright, the next one we're going to do is example 10. So example 10, we're going to do the same thing. We're going to write it out over here. And we're going to multiply the corners. So this becomes radical x squared, negative 2 times radical x, positive 2 radical x, and lastly is negative 4. What is the square root of x squared? Good. What happens to these two terms here that are like terms? They cancel out. So all I'm left with is the negative 4, so your answer is x minus 4. So we're going to do the top of the next page and then we'll take a break. So your next page is dividing radicals. So when you divide radicals, it's very similar to when you multiply them. You're basically going to put them underneath one big radical, and you're going to have whatever a is divided by whatever b is. And within that, you should be able to simplify. So in this case, we're going to put it over one big radical. So it's going to be square root of 18 x to the 5th over 2x to the 3rd. So what is 18 divided by 2? 9. And then when you add, or sorry, when you multiply variables to different exponents, you add them. So what do you think you do when you divide them? Subtract. So what's 5 minus 3? 2. So this simplifies to 3x because the square root of x squared is x. So any questions about this one? Okay. Next one is example 2. So these are third root, so make sure you put it under one big third root, not a square root. So this is 162 y to the 5th over 3y squared. What an example. I don't remember until I get through the problem. I'll tell you. You'll see in a little bit, but I don't think it's going to be x because there's no x in it. I mean y. So this one here is going to be, so yes, but there's no x in the problem. So 162 divided by 3 is what? Yeah, 54. And then what's y to the 5th divided by y to the 2nd? Y to the 3rd. I think you're right though. And then this one groups up into groups of, we're trying to group it up in groups of what? 3. So this breaks up into 9 and 6, which breaks up into 3 and 3, which breaks up into 3 and 6. So we're looking for a group of 3's. So this becomes 3 and then we have the y, right? 3y, and then the 3rd root of 2. So that would be your final answer. Alright, so from here, we're going to give you a 10-minute break, but you guys, we do have a bit to do when we come back from the break, so make sure that you're ready for that. The main idea here with rationalizing the denominator is when your answer is finalized, when you give me your final answer, there needs not to be a radical in the denominator. Okay, if there is one, we need to do a process called rationalization. Rationalization is the process where we have to figure out what we need to multiply the denominator by, okay? So I know that if I have a regular plain old square root, if I just multiply it by the same square root I have in my denominator, that's actually going to cancel out the square roots in the denominator or get rid of them. So in the numerator, whatever you do to the denominator, you also need to multiply the numerator by. So that's going to become 3 square root of 2x over. Now, whenever you multiply something by itself for square roots, it's just going to be whatever's inside. But if you don't believe me, we'll do it, the long way. So this is going to be 2 times 2, which is 4, and then x times x, which is x squared. So what is the square root of 4? Good. And what's the square root of x squared? X. So this is your final answer. And as you can see, we got rid of the square root in the denominator by using the process of rationalization. The reason that this process works is because you can take any fraction and multiply the numerator and denominator by the same thing, and it still maintains the integrity of the fraction. Just like 50/100ths is the same thing as 1/2. So now we're going to move on to example 4. Now in this case, we don't have a square root in our denominator, we have a what kind of root? Cube root. So cube roots are a little bit more tricky to rationalize. So you have to think of what's going to make this root go away. So the easiest way, in my opinion, to think about it is, you need to pair up numbers in groups of what to get rid of one of these? Get it out of the 3rd root. Groups of 3. So basically, I know that if I want to get rid of the 2, I'm going to need 2 more 2's, right? So 2 times 2. If I multiply 2 times 2 times 2, it's going to be 8, which will take a 3rd root. And then I need my x to be to what power to get rid of the root? Well, we'll get it out of the 3rd root. It needs to be to the 3rd power. So if I multiply x squared by x, that'll get rid of the power. Okay? It's weird, but you'll see. So this becomes right here the 3rd root of 4x over, we're multiplying by the 3rd root of 4x again. Now your numerator becomes 2 3rd root of 4x, and your denominator we're going to do out on the side. So when you multiply 2 3rd roots together, you're going to put it all under one big 3rd root. So 2 times 4 is what? Yeah, 8. And then what's x squared times x? X to the third. What's the third root of 8? 2. What's the third root of x squared? X. So do you see why we picked 4x to work, to get rid of it? See how it got rid of the root. Now the easiest way, like I said, to figure it out is whatever number you have in here, if it's the third root, you're going to multiply it by 2 more 2's, because that will get it into a group of 3. So that would be 4. And if I have an x squared, I want to get it to x to the third to cancel out the root. So I'm going to multiply whatever I need to multiply it by to get rid of that, to get it to the third power. So what to get it to a perfect third root, and what to get it to the perfect third power. Now once we get to this step, we should be able to cancel something out in the numerator and denominator at this time, and what is that? The 2. It's multiplication, so this will just become third root of 4x over x. And this is your final answer. So sometimes you just have to be a little bit creative about figuring out what to multiply by to get rid of that radical. If it's a regular square root, it's pretty easy. It's usually just itself. But if it's a third root or a fourth root, it can be a little more complicated. So I'm not going to give you any really hard ones, though. So let's go ahead and look at example 15. I need to get this out of the denominator, okay, the radical. So the first thing you're going to do is look at what kind of radical it is. It's a fourth root. And we know that for a fourth root, we need things to be in groups of 4. So I know that if I want my 2 to cancel out, I'm going to need 3 more 2's to get a group of, I'm going to need to multiply it by 3 more 2's to get it to a group of 4. And then to get my x to the fourth power, because I want it to be the fourth power, I'm going to need to use how many more x's? 3. And then to get my y to the fourth power, I'm going to need how many more y's? 2. So that's what you're going to multiply the numerator and denominator by. The fourth root of, this is going to be 8, x to the third, y squared, over fourth root of 8, x to the third, y squared. Now we're just going to multiply this straight across. So this is just going to become 2 fourth root of 8x to the third, 8x cubed y squared, over. And now here, we're going to have to multiply these two together. So I'm going to do that on the bottom so we have some room here. Okay, we're done with that, so I'm going to do it at the bottom. So what is, we're just going to multiply everything inside the fourth root. So what's 2 times 8? 16. What's x times x cubed? Good, and then it's going to be y to the 2 times 2 plus 2. 4. So your goal is to get it to cancel out the fourth root, and now it's going to, right? So anybody remember what the fourth root of 16 is? It's a perfect fourth root. 2. Fourth root of x squared is just, or x to the fourth is just x, and fourth root of y to the fourth is y. So we picked that for a reason, because now everything's canceled out, all the roots. And then we can cancel out the 2 in the numerator and denominator. And our final answer will be the fourth root of 8x cubed y squared all over xy. So get that down, look it over. Alright, let's go ahead and try 16. Do you need this still? So number 16 is a little bit different. What do you notice about the denominator this time? Do we have just one root?
2.
2. So this is where we use what's called the conjugate. Anybody remember what the conjugate is?
No.
So the conjugate is where you have to multiply something by its inverse. So all you do is you change the sign between the two. So if you're trying to get rid of something with a square root that has a plus minus, you're just going to multiply it by its conjugate, which is just where you change the sign in the middle. Okay? So we're going to multiply the numerator first by using the distributive property. okay? And that's going to become 2 radical 21 plus 2 radical 35 all over, and then we're going to have to multiply these two together. So do you remember on the last set of problems we were doing, how did we multiply those two together? We used the box, right? So we're going to make a box. And I'm going to multiply these two together using the box. So this is the square root of 3 minus square root of 5, square root of 3 plus the square root of 5. And I'm going to multiply the corners together. So radical 3 times radical 3 is radical 9. Radical 3 times radical 5 is radical 15. Radical 3 times negative radical 15 is negative 1, basically, radical 15. Same thing as negative 1 in front of it. And then lastly, negative 1 radical 5 times radical 5 is negative 1 radical 25. Now once you have everything in the box, you can go ahead and simplify where possible. So this simplifies to 3. And then what happens to these two, the radical 15s? They cancel. And then what is the square root of 25? 5 times negative 1 is? So we have 3 minus 5, which is negative 2. So this whole thing, when you multiply these two together, comes out to be negative 2. So that's what goes down here. And now in both cases, I have a 2 that I technically could factor back out, right? So if I factor out a 2 in the numerator, so you good with how we got this stage? So all I did was I factored out the 2 in the numerator, just by dividing these both by 2 and pulling the 2 out. And then since I do that, I can now cancel this out. So 2 divided by negative 2 is just negative 1. So this just becomes negative 1 times radical 21 plus radical 35. And you could also distribute the negative 1 back into that if you wanted to. So either way is fine. And that would be your final answer. So like I said, these are just a lot of being really good with your algebra skills, okay? So last one that we're going to do together, and then we'll do 18 individually, we'll try it out, is 17. So for number 17, we're going to multiply my numerator and denominator by, we're going to take this and we're just going to change the sign in the middle. That's how you know what to multiply by. Because this is a method that will help us cancel out the root in the denominator. Now in the numerator, we should be able to use the what property? Distributive, good. So this comes out to be 12x plus 4 radical 5x. So I just use the distributive property to multiply that together. Everybody see how I picked what I picked, or why I picked what I picked? Why? So the reason why is because these are what we call difference of squares. And they're useful because whenever you multiply difference of squares together, you're always going to cancel out those middle terms. So that way the roots go away. So that's why we do it.
Why do we do it on the ones above it?
Because this one didn't have a sum or difference to even do. So here we had to work with something that was going to multiply it by something that's going to make it take the square root or the fourth root or whatever root it is. So you have to figure out what can I multiply something by to make it a perfect root. So like for example, square root of 32, if I multiply it by the square root of 2, it's now going to be square root of 64, which takes square root of 8. So you're figuring out what that is. So back to number 17, we're going to multiply these together. Now you can use the box method that we had been using in the previous few questions if you like. I'm just going to do it by FOIL to do something different to show you. So I'm just using FOIL, but box method works too, your preference. First times first, so 3 times 3 is 9. 3 times radical 5 is 3 radical 5. Negative radical 5 times 3 is negative 3 radical 5. And negative radical 5 times radical 5 is negative radical 25. So the whole goal with the conjugate is that these middle terms will cancel out. Okay, that's always going to happen when you use a conjugate. That's what's really useful about them. And then we're just left with 9 minus 5, which is, because it's square root of 25, which is 4. So we're left with this. But can we factor a 4 out of the numerator to cancel it out with the denominator? Both of these numbers are divisible by 4, right? So we can actually factor out a 4 in the numerator. So this becomes 4 times 3x plus radical 5x. So all I did was I just factored out a 4, and you can check that by distributing the 4 back if you want to. Now, I did that because now these 4's cancel out, and now I just have this as my answer. It's a lot more simple of an answer. So that's my final answer. So what I'd like you guys all to do now, and I will come around to work with you, is I'd like you all to try number 18 on your own. So go ahead and try number 18. So this is the answer to number 18. You distribute a negative or a positive 1 onto both these, and it just stays the same, because anytime you multiply something by 1, it just keeps it the same. And then for your denominator, you either need to use area model, box method, or you can use FOIL. Your middle terms will cancel out when you multiply by the conjugate. And then the square root of x squared, because x times x, is just x. So that's how you do it.